Hello everyone and welcome back to Diksha Karnataka YouTube channel, and today is day 30 of your PU2 Brahmastra series, and I am going to discuss a very important chapter for your second PU exam, dual nature of radiation and matter. I have received a lot of requests from many of you that sir please discuss this chapter. So this week we will complete most of the important chapters, and from next week onwards we will be doing some of the medium important chapters as well. So first let's look into the weekly schedule of this week. Monday chemistry, electrochemistry is already done. Today I am going to do dual nature of radiation and matter. Wednesday biology ma'am will be discussing biotechnology and its application. Thursday chemistry, chemical kinetics, okay, and Friday I'll be back with semiconductor, another important chapter. Then maths and biology combined on a Saturday, differential equations and reproductive health. Then Sunday will be only purely maths, then linear programming will be discussed, right? So entire week's schedule is over here. So if you have any doubt, any questions regarding sir what will be being taught in the upcoming week, so entire schedule I am giving it to you so that you can be ready with your notebook, with your pen, so that you don't miss out on anything. Okay, now here let me discuss about a very important thing for your second PU exam. So Diksha has launched PU2 success blueprint test series, which is already live since last Sunday. First test paper is already out, the first exam is already over. Okay, solutions is also available in the Novo app. So what is this test series is about? In the test series you will be getting 12 mock test question papers. Okay, out of that one question paper and its solution is already available, but you can, even if you join right now, you can download the question paper, solve it, then you can check the answers. Stay true to yourself. So question papers you will still get, okay, even if you are joining right now, you will still get all the question papers. So right now what we are giving you, we are giving you 4-part test. Part test consists of physics, chemistry, maths and biology. Okay, 25 marks each from every subject, and that will be 4-part tests that will cover your entire syllabus. Okay, once your entire syllabus is over, then you will be also getting 8 full syllabus question papers that will include 2 full question paper from each subject, physics, chemistry, maths, biology or CS. So that 8 full question papers you will get from this thing, and we will be giving you, first of all, this will be purely focused for your PU board exam, and you will not only get the PDF solution for this question paper, you will also get a video solution by one of our expert teachers. Okay, so each subject wise we will be giving you video solutions for that as well. Okay, and any doubts that you might have from that question paper, that will also be clarified through our Novo app. So only thing that you have to do, you have to click on the link below, okay, then fill up your descriptions and then pay this 599, only 599 rupees, and then you can join this program. Okay, now let's go back to our discussion of blueprint of this chapter. So the blueprint of this chapter is divided like this. So first, blueprint number 1, that gives us 5 marks from this chapter. And how 5 marks? 1 mark MCQ from this chapter compulsory, 1 fill in the blanks, okay, that is also almost compulsory. Then there will be a 3 mark short answer type question from this chapter. Okay, then there will be 1 MCQ, again 5 marks, 1 fill in the blanks, again 5 sorry, not 5 marks, my mistake. Blueprint 2 also giving total marks 5, and it is exactly as same as blueprint 1. Only thing is, this question is remembering based, this question is slightly understanding based. That is the basic difference. Okay, other than that there is no difference between blueprint 1 and blueprint 2, but there is a significant difference in blueprint blueprint 3. In blueprint 3 you are supposed to get 6 marks from this chapter, and one will be MCQ, another one will be HOTS numerical question. So we don't have any 5 marks long answer type question from this chapter in this year. There was a 5 marks long answer type question last year, which was a split type question, where there used to be different types of split questions, 1 plus 1 plus 3, 3 plus 2, like that type of question used to come. Now this year only 3 marks question is going to come, or a numerical is going to come. So you will be solving all these things. So let's see the paper distribution. So we will be solving, and I think there is a change in this thing. There will be 3 numerical questions, so 1 bonus question will be there. Okay, so what all we are getting here, you will be getting 15 MCQs as usual, then 5 fill in the blanks, then you will be also getting 3 marks question 3, and 3 full long answer type numerical questions, right? Let's start with the MCQs. The emission of electrons from a metal surface by heating is called, so emission of electron by the method of heating is called thermo-ionic emission. Thermo-ionic, thermal ions. Okay, heat means thermo, anything related to the heat is thermo. Okay, thermo-ionic emission. Next, in photoelectric effect experiment, if only the frequency of incident radiation is increased, then the maximum kinetic energy of the photoelectrons decreases, the stopping potential increases, the photoelectric current increases, the photoelectric current decreases. So from the relationship between frequency and stopping potential, the stopping potential will be increasing. Stopping potential will increase, more reverse potential is required, but current will not change. Photoelectric current depends only on the intensity of the radiation, so it is independent of the frequency photoelectric current, but stopping potential is, or the maximum kinetic energy, that is also dependent. So basically if they ask you maximum kinetic energy increases, yes, that is correct, but in this case they have given you decreases, so that is obviously not correct. So kinetic energy and stopping potential, which are actually cousin brothers, because you have to multiply a factor to convert them, so they are same thing, one or other, they are same thing. So kinetic energy and stopping potential depends on frequency, whereas the maximum current or saturation current or current, that depends on the intensity of the incident radiation. Okay, now next question. The de Broglie wavelength of a moving particle is independent of dash of the particle. Okay, so de Broglie wavelength depends on mass, de Broglie wavelength depends on speed, and obviously momentum. Then it is independent of charge, so correct answer is charge. So if you remember the de Broglie wavelength formula, it is basically momentum depends on momentum. So momentum is basically the multiplication of mass into speed. So it depends on mass, it depends on speed, it definitely depends on momentum. So basically from there you can say it is independent of charge. It does not depend on the charge. Okay, it only depends on mass and speed, basically momentum. Now following are the statements related to photo emission. Photoelectric current is independent of intensity of the incident radiation. So this is not incorrect. Photoelectric current does depend on the intensity of the radiation. Okay, only thing is that, as I said, photoelectric emission, maximum kinetic energy and the stopping potential, that depends on frequency, but photoelectric current depends on the intensity of the radiation. So this statement is incorrect. So this statement is incorrect. Okay. Stopping potential is different for different photosensitive metal surfaces. For a radiation of particular frequency, nu is greater than nu naught. So basically if the incident intensity is greater than the threshold frequencies, then definitely stopping potential is different for different photosensitive material. That is correct statement. Okay, whatever the for stopping potential for example say zinc is different for another metal, say iron. Okay, so different metals have different photosensitivity, that's why not all metals are same. maximum speed of photoelectrons is independent of the frequency of the incident radiation. No, maximum speed of the photoelectron depends on the frequency. It is independent of the intensity, but it does depend on the frequency. So this is also a wrong statement. Saturation current is different for radiations of different intensities having same frequency. Yes, this is also correct statement. Saturation current does vary with the different intensity. Okay, this is the saturation current. So if the intensity is different, for same frequency they will have the same stopping potential, but saturation current will change. So basically, as you know, that this is the stopping potential, they will merge here, if you remember the graph. Okay, so my lecture is assuming that you have at least read the book once. If you have not done so, or you have watched my cassette videos, if you have not done so, please go back, check the book at least once, or check my cassette videos. Okay, so as you can see, option 2 and option 3 are correct. So 2 and 4 are correct. Only 2 and 4 are correct. So option D in the given question, option D is the correct answer. Okay, so slightly higher level question, because you have to first identify the correct statement. From there you have to identify the correct answer. Right, now next question. Davison-Garmer experiment proved the wave nature of electron, the particle nature of electron, the wave nature of light, the particle nature of light. So Davison-Garmer experiment proved that the wave nature of electrons. Okay, next question. Macroscopic particles in our daily life do not show wave-like properties. This question is from 2024 exam. So as you can see, macroscopic particles, macroscopic, what is the meaning of macroscopic? So microscopic means the very small objects which you need to see under the microscope. Now macroscopic particle means everything that we can see around us in our open eyes. For example, you, me, okay, this blackboard, okay, everything, your mobile phone through which you are watching, or your laptop through which you are watching. So all these are macroscopic objects. Okay, now wave properties means, as you have seen in your science fiction movies, wave properties means we should have, if I was a wave, I could have moved through your device directly and come out and talk to you directly over the phone, right, face to face. Instead of talking over this device, I would have come out, I would have used this technology, I would become a wave, I would come out from your mobile as soon as you started this video streaming, and I would have had a discussion, I would have explained it to you personally, then I can come back. So wave nature, if that is true for everyone, then I could have become a wave and I can travel anywhere at the speed of light. But that is not happening. Why that is not happening? Because the wavelength for us is negligibly small, it's almost zero. Okay, so this question was slightly controversial in 2024 because the wavelength is practically zero. Okay, and you can say that negligibly small, both are actually same statement. So that's why there was some confusion among students. Okay, even though they have admitted that only option D was correct answer. Okay, because practically, even though they are practically zero, theoretically you can find its value to be 10 to the power of minus 60, minus 70, minus 80, minus 90. That is practically not zero. That's why they said it is technically zero, even though the 10 to the power of minus 100 means obviously it's a zero. Right, so the probability of us being a wavelength is very, very small, right? So our wavelength is so small that we will not be able to even be able to pass through anything, right? So the wavelength is negligibly small, so that's why we cannot behave as a wave. And to be for us to become a wave, we have to move at the speed of light. So then only it is possible for us to behave like a wave. Otherwise, it is not. Even that, for that also we will may not be able to become a wave. If you study science in future, then you can you will learn about more about this thing. There is something called Schrodinger equation, probability. You can find the probability of you becoming a wave even if you move at the speed of light. Okay, now the wavelength of matter wave is known as de Broglie's wavelength. Okay, very important, very common to know that. Next question is question number 8. Field emission in emitting electron on applying electric field, magnetic field, light, heat. So field emission is when you apply heat, not heat, electric field and electrons are getting emitted, so that is called field emission. Okay, next is photoelectric emission is emitted electrons on applying obviously light. Photoelectric emission, photo comes from the term light. Okay, photo means light, so whenever you hear the term photo, so then you see that, then you have to answer the option light. So same question, they will change the name. So field emission, photoelectric emission I have mentioned. Thermoionic emission, they will mention thermoionic emission, then you have to identify heat. Okay, there is no emission due to magnetic field, but still so these are the things that you have to remember. Thermal emission or thermoionic emission is basically heat. Okay, field emission is electric field, not magnetic field, and photoelectric emission is light. Okay, now next question. According to de Broglie, the material particles exhibits wave nature only at rest, only in motion, only when kept at rest in a magnetic field, only when kept at rest in a electric field. So de Broglie wavelength is visible only when the object is in motion, because it depends directly proportional to the momentum. Right, so if the object is static, you will not see any wavelength. Right, now next, photoelectric effect was discovered first. So photoelectric effect was first discovered or first observed. So who was the person who first observed photoelectric effect? This question is very interesting question. Okay, in your book, might after reading the question you might find, okay, Einstein is the answer. Actually it is not even Hallowach and Leonard. The correct answer is Hertz. Heinrich Hertz is the first person who observed photoelectric effect. Okay, so that's why this is an interesting question. Even though they Hallowach and Leonard gave some explanation to that, Einstein got Nobel Prize because of this, explaining this theorem, explaining this phenomena. But the first person who observed this, Heinrich Hertz, who died at very young age, and he didn't get any single Nobel, even though he is famous for a lot of things. Even the unit of frequency is named after Hertz, right? But he didn't get a Nobel Prize. He died at a very young age because of some illness that he had. So be careful, this question might come in your exam, so you have to be careful and you have to answer Hertz. Okay, next question. The minimum frequency required for photoelectric effect is known as minima, threshold frequency, Einstein's frequency, de Broglie's frequency. No, it's not Einstein frequency, it is not de Broglie's frequency, obviously not minima, it is called threshold frequency. Right, we already know that the minimum frequency required for photoelectric effect is called threshold frequency. From there you can even write the definition of threshold frequency. Right, next question. Einstein's photoelectric equation is in accordance with the, what is the fundamental of Einstein's photoelectric emission? So any fundamental, any accordance with, or it implies the, so they are basically means the conservation laws. Okay, there are different conservation laws. Most important conservation laws are conservation of energy and mass obviously combined together, and conservation of charge. Okay, so here you have to check which one of them is correct. Conservation of mass only, conservation of charge only, conservation of energy only, conservation of momentum only. So basically conservation of energy includes both mass and energy. So conservation of energy is the go-to here. Okay, mass is obviously, in this case we are not considering the mass, only thing that we are considering is the energy. So Einstein's photoelectric equation is basically a form of conservation of energy for the photoelectrons. Okay, next question. In photoelectric experiment, if both the intensity and the frequency of the incident light are doubled, then the saturation photoelectric current is doubled, remains constant, becomes 4 times, is halved. So as you increase the intensity, okay, both intensity and frequency of the incident light are doubled. Okay, so then the saturation photoelectric current. Now saturation photoelectric current depends only on intensity. Saturation photoelectric current depends only on intensity. It has nothing to do with frequency. So if you double the intensity, then photoelectric current will be doubled. Okay, sorry, not constant, it will be doubled. Okay, so this is simple answer. Sorry, my mistake, it's doubled. Okay, so photoelectric current will be doubled. Next question, question number 14. The maximum kinetic energy of the photoelectron depends only on. So the maximum kinetic energy of photoelectron depends only on the frequency. Okay, only on the frequency, does not depend on incident angle, potential, pressure. Okay, it depends only on frequency. Next question is, light of certain frequency and intensity incident on a photosensitive material causes photoelectric effect. Okay, the incident radiation is made exceedingly dim. So what you have a, suppose you have a light, say red light or say violet light, okay, and you are lighting it on a zinc surface. So there was photoelectric emission happening. Okay, so light of certain frequency and intensity incident on a photosensitive material causes photoelectric effect. That means, what is the meaning of the first part? What is the meaning of the first part? First part is only to introduction, where it says that okay, the incident frequency is greater than the threshold frequency. If in case the frequency of light is less than threshold frequency, there will be no photo emission at all. Okay, so in that case this question is not meaningful. So but they have said that there is a photo emission, that means obviously the incident frequency is greater than the threshold frequency. Now you have decreased the intensity. Make exceedingly dim means the intensity is decreased. So for example, you are lighting up say 100 violet LED on a surface and you are getting some photo current. Now instead of lighting up 100 LEDs, now you are only lighting up only one single LED. You have switched off all the 99 remaining LEDs. Now the light coming from that one LED is very small, right? So intensity you have decreased it. So now what will happen to the photo emission? So photo emission will cease to exist. There will be no photo emission. Photo emission will continue, but saturation current will decrease. So photo emission will continue, but the saturation current will decrease. Photo emission will continue, but the saturation current will increase. Okay, none of the above means photoelectric current may continue, may not continue. Saturation current may increase, may decrease. So basically in this case, as you have decreased the intensity, the saturation current will decrease, but the photoelectric effect should continue. Okay, photoelectric effect is independent on the intensity of the incident radiation. It only depends on the frequency. Since the frequency is fixed, so photoelectric effect will continue. Only thing that it will change, the current will decrease. Okay, more the light, more the current. Less the light, current will decrease, but photoelectric effect will continue. Now let's look into the fill in the blanks. In the interaction with matter, the light behaves as if it is made up of packet of energy called. So packet of energy, we know that the name in the given option, frequency, wave, intensity, particles, photons. Yes, this looks similar, right? So answer will be photon. In the incident interaction with matter, the light behaves as if it is made up of small energy packets. These energy packets are called photons, right? The charge of a photon is, so what is the charge of a photon? Charge of a photon is 0. Okay, charge of a photon is 0. Photons does not have any charge. Next is the even in case they ask one more question, is that instead of charge they might ask you rest mass. Rest mass, maybe a new term to you. Rest mass means if you take the photon, if you stop it for some time, okay, and if you try to measure its mass, then that mass will be 0. That is called rest mass. So rest mass of photon is 0, okay, and its charge is 0. So that's just two terms that you have to remember. The maximum kinetic energy of a photoelectron depends only on the dash of the incident radiation. So the maximum kinetic energy, as I mentioned earlier, that kinetic energy depends only on the frequency, right? Next, the saturation current in the photo emission depends on the intensity of the incident radiation. Okay, a fast moving electron will behave as a wave. Okay, so all the questions we have answered correctly. I just check the answer. This is very simple. Okay, chapter is simple, concept is simple. Okay, so maybe they will add questions. Obviously fill in the blanks is not from one single chapter. They will mix different chapters and might be confusing to you, so be careful. Be clear in your head what you have to answer, then you can answer such questions. Next, give Einstein's explanation of photoelectric effect and write Einstein's photoelectric equation. So Einstein's expression is suggested that each photon of light has energy proportional to its frequency nu, given by E is equal to h nu. Okay, she is the first person who suggested that energy is dependent on the frequency and it is given by h nu, where h is the Planck's constant. When light shines on a metal surface, photons transfer their energy to the electrons in the metal. Okay, any energy from the photon exceeding the work function becomes the kinetic energy of the ejected electron. So these two answer. So whenever you are shining light on a metal surface over particular frequency, okay, electrons, so that photons actually transferring its energy to the electrons. Okay, so whatever energy, whenever you are shining light onto a metal surface, the light is transferring the energy into the surface, okay, onto the metal, electron. Okay, now any energy from the photon exceeding the work function becomes the kinetic energy of the ejected electron. So there is a new term called work function. We will see that in a while what is work function is. So whenever the energy that you are providing is more than the work function, the electron will start to move, so they will have a kinetic energy, right? So this is very important, and we will see more about this equation. This equation part is pending. We will come back to it with a new question where we will only discussing the equation. So right now I am not answering this equation part. It will be covered in a later question. So now let's see the next question. Give any three results of experimental study of photoelectric current. Very, very important. These two questions are very, very important question from this chapter. Most often asked, okay, Einstein's observation and three results. Okay, so these are the things that you can write from there. For a given metal, no electrons are emitted if the frequency of the incident light is below a certain minimum value called the threshold frequency. So this is very important. Okay, the threshold frequency. So if the frequency is below this certain limit, there will be no photoemission. To photoemission to happen, okay, this has to be, the incident frequency has to be more than this value. Okay, regardless of the intensity of light. So for example, if red light does not invoke any photocurrent, it does not matter if you switch on 1 LED or 100 LED or 1000 LED or 1 million LEDs. Okay, so if red light does not invoke photocurrent, even 1 million LEDs will also not help. But if say violet light invokes photoelectric current, okay, even one small LED is sufficient, even half LED, even a masked LED is sufficient for photocurrent to appear. Okay, so this is very, very interesting that the photocurrent is not dependent on the intensity of light, but it is dependent on the frequency of the light. The photoelectric emission occurs without any noticeable delay after the light strikes the surface, even for a low light intensity. So it is an instantaneous process. That's why it is called, photo emission is called an instantaneous process. So as soon as you switch on the light, the electron will start to come out. The maximum kinetic energy of the emitted electrons increases linearly with the frequency of the incident light above the threshold frequency. This is also very, very important, that as the maximum maximum kinetic energy obviously is linearly with the proportional to the linear function of the frequency, right? So as frequency increases, maximum kinetic energy also increases. Okay, now what is meant by photoelectric effect? what define work function, define threshold frequency. So as I said, I will give you the other parts also. So one question may leave some doubt in your mind: what is threshold frequency, what is work function, okay, what is photoelectric effect. So everything will be answered here. Okay, the photoelectric effect refers to the phenomenon where the electrons are emitted from the surface of a metal when light of a certain frequency or higher shines on it. These emitted electrons are called photoelectrons. So when you very interesting, right? So electrons are very interesting and very necessary in our life. Okay, without electrons you will not be able to watch this video in your device. Without electrons the light would not shine in your house. Without electron your entertaining light, your PUBG time will not be possible, right? Even we would have stayed in the dark ages if the electron was not discovered, right? So electron plays the major role in all of our daily life. He is the one of the smallest particle, but he is the most important particle of our entire life, even more important than proton, right? In a sense, even proton and electron are brothers, twin brothers, but and they are fighting always because proton is the center and electron is orbiting. But electron is the most important particle as a single particle, because it creates the electricity, right? It carries the electricity, not creates, it carries the electricity. Now if you have seen solar panels is basically a industrial application of photoelectric effect. Okay, so industrial application means when the sunlight falls on the solar panels, it emits electrons. Those electrons are carried by the wires connected to it. Okay, slightly just a simplified version I am talking about. Okay, those electrons then lights your home, okay, your mobile, your laptop. That is one of the process. There are other process also, but electric current, one of the common example is the solar light. Okay, so basically when light shines on certain material, they emit electrons. Okay, those electrons can be collected to make a current. Okay, so that current is called photocurrent, and the emitted electrons are called photoelectrons. Now the work function phi is the minimum energy required to eject an electron from the surface of a metal. It is property of the metal and is typically measured in electron volts. So what is the threshold frequency? Threshold frequency, so this is the photoelectric current, this is the work function. Okay, work function is the minimum energy required. So if I want to tell you, okay, please do your study, okay, or if I say, okay, you have to score 90% in your PU exam, then you will say what I will get in return. So there is a minimum wage, minimum amount that you are expecting from your parents, from your teachers. Okay, if I get 90% in my PU board, then I will have at least 1 week off. I will play PUBG full time. Okay, no disturbances. Or you might say, if I score 90% in upcoming exam, then you will give me a treat in a hotel, or you will give me a treat in your home. You will give me the most delicious food that you can prepare. I want to eat. Okay, these are the little incentives that you might ask. Okay, if I score, this is the minimum percentage, right? This is the minimum wage. Even your parents will say, if you score 90%, I will give you, and in our times it was a cycle. Now in your times many will say, I want a scooter, I want a bike, but just for a discussion perspective. So these are the minimum things based on how much you are scoring, how much you are loved by your parents. So you can demand certain amount of gifts, right? Similarly, the electrons, they also are like you. Okay, they also require a minimum amount of energy to come out of the their home and do carry the electricity, right? So that minimum amount of energy is called the threshold work function. Okay, that minimum frequency of that wave is called threshold frequency. Okay, so the minimum amount of energy required to release one electron from the valence shell to the conducting shell, that we have already learned in our semiconductor physics in our cassette lecture. If you have not, we will be discussing that again in our this week's last video. Okay, physics last video of the week. So there we will be discussing semiconductors, but till now you should remember that to push the electron out of the home, the minimum energy required is called the work function. Next is the threshold frequency. The threshold frequency nu naught is the minimum frequency of the incident light required by to cause the emission of the electrons from the surface of the metal. For light with frequency below nu naught, no electrons are emitted regardless of the light's intensity. Now there is a relationship between work function and threshold frequency. Okay, the work function phi is basically h nu naught. So this is the relationship between, so they are basically one or other sense they are brothers. Okay, only thing is there is a h involved, otherwise they are same. Okay, so one is elder brother, one is younger brother, right? Now, so as I said, next question is mention Einstein's photoelectric equation and explain the symbols. Sometimes this kind of question is also possible to come. So let's see Einstein's photoelectric emission equation. So Einstein photoelectric emission equation is h nu is equal to phi plus half mv square. Okay, sometimes it is written as, there are different forms possible. H nu is equal to h nu naught plus k max. Okay, or instead of k max, half mv square is also written, or this equation can be also written as h nu minus nu naught equals to half mv square. So there are different forms that you can write from this thing, but this is the most easy to remember, easiest form. These forms are important sometimes for solving numericals. Okay, other than that, this is the sufficient formula for this question. Okay, in the previous question also, where they have asked you to write the Einstein's equation, you have to write this equation. Okay, now what are these terms? Here h is called Planck's constant. It is approximately 6.626 into 10 to the power of minus 34. Then frequency of the incident light 34 joules. Okay, frequency of the incident light is, I think it is not exactly joule, it is joule per, it is joule per hertz. Okay, or joule second. Basically hertz means 1 by second, so joule hertz means joule second. So that is the Planck's constant. Frequency of the incident light is nu. Phi is the work function of the metal. Mass of the electron is 9.11 into 10 to the power of minus 31 kilograms. V is the velocity of the electron. So these are the terms that you have to remember and you have to write whenever you are writing this equation. Okay, now next question is the numerical question. So you have already completed all the short answer type, important short answer type questions. All the questions that I have discussed in this chapter are very important, so you cannot skip all these questions. All the questions are important. Okay, now let's solve the numerical questions. When light of wavelength 400 nanometer is incident on a photosensitive surface, the stopping potential for the photoelectrons emitted is found to be 0.96 volts. Okay, when the light of wavelength 500 nanometer, okay, is incident on the same photosensitive surface, the stopping potential is found to be 0.34 volts. Calculate the Planck's constant. So this problem might be, you might find this problem difficult if you are solving numericals for the first time in your life. If you have solved any chapter numericals, from any of the chapters, then this problem is not super difficult. So what we have to do, first we will write the Einstein's equation for these two waves. Okay, then we will put the values. Initially we will not put the values. So for first light is wavelength is 400 nanometers. Okay, the first wavelength is 400 nanometers. So first case is h nu 1. Now remember that nu, there is a relationship between wavelength and frequency. Here it is given in terms of frequency. So h nu 1 is equal to phi. Now for a given material, the work function is constant. So phi plus k 1. K1 is the kinetic energy, right? So kinetic energy, also kinetic energy can be written as in terms of work function. In terms of work function, so I forgot to mention in the previous case also. So sometimes this is also written as H nu is equal to phi plus E V naught. Here this V naught is called the stopping potential. Okay, so this is called the stopping potential. So this is also another form of Einstein's photon radiation emission, and here E is the charge of an electron. I hope you know the value, right? 1.6 into 10 minus 19 coulomb. So this is also one of the forms. Okay, so this is the mostly used from form number 1. This is the second used from form number 2. This is the third used from form number 3, and from here this is the form number 4, very less used, but still might be helpful for you to solve some problems. Okay, now let's move on to this question. So stop here they have mentioned that first case the stopping potential to be 0.96 volts. So stopping potential is V1. Now same thing, same material is used with a different frequency, and it was observed that the stopping potential is different now. Okay, what is the stopping potential? Say V2. We are not putting any values right now. Why? Because eventually we want to eliminate this work function, right? So work function needs to be eliminated. Till then we will only use the constant values. So H nu 1 minus nu 2 is equal to E V1 minus V2. And what is our target? Our target is calculate the Planck's constant. Now in this equation, what is Planck's constant? In this equation, Planck's constant is this H. So what we are trying to find? We are trying to find H. H equals to E V1 minus V2 by nu 1 minus nu 2. Okay, so if we can somehow find these values, then definitely we can calculate the Planck's constant. Now first what we will do, we will calculate nu 1. What is nu 1? Wavelength is 400 nanometer. So lambda 1 is 400 nanometer. Right? So 400 nanometer means 400 times 10 to the power of minus 9. Right? Or you can simplify it to be 4 times 10 to the power of minus 7 meters. Right, everything should be converted into meters because eventually our final answer should be in meters. So this is the first step. Okay, and lambda 2, from there similarly you can write lambda 2 is 5 times 10 to the power of minus 7 meters. Right, lambda 2 was 500 nanometers. Now let us calculate nu 1. What is nu 1? Nu is C by lambda. Okay, so these are the relationship that you have to remember. Nu is C by lambda. Okay, what is C? C is 3 times 10 to the power of 8, and by lambda, lambda is here lambda 1. Lambda 1 is 4 times 10 to the power of minus 7, or 3 by 4 times 10 to the power of minus 16. Sorry, not minus 16, plus 15. This will go up, minus 7 will go up, and it will become 8 plus 7, that is 15. Okay, so this is the nu 1. What is nu 2? Similarly, nu 2 also we can write 3 by 5 times 10 to the power of 15. Same thing, right? So nu 2 will be only this 4 will be changed into 5. Right, now this is not done. We are supposed to find, if you observe the question, we are supposed to find nu 1 minus nu 2. Okay, so we have to calculate that. Now calculate that. Nu 1 minus nu 2 is equal to 3 by 4 minus 3 by 5, and this 10 to the power of 15 is common. right? So 10 to the power 15 is common. Even you can take the 3 also as common. So let me take that as also as common. Okay, 3 is common, 1 1. Now what is the LCM? LCM is 20, right? 4 5s are 20, 4 5s are 20 times 10 to the power of 15, or you will get nu 1 minus nu 2. Nu 1, not this, looks like gamma, this is not gamma, this is nu. So there is a difference between gamma and nu. Gamma has a, so if you are writing gamma, gamma has like this, there is a curve like this. It's more like a I write R like this. So gamma is like a, there is a tail, but when you are writing nu does not have this tail. Okay, so gamma has this tail. So sometimes I used to get confused when I was a student, no one explained me this. So the teacher used to think that, okay, you know gamma, you know nu. So nu is like this. Okay, nu is the Greek letter for Greek letter N, and gamma is like G. So they have different meaning. So that's why their symbols are also different. Okay, so now 3 times 5 minus 4, 4 from 5 minus 4 is 1 divided by 20 times 10 to the power of 15. Or if you cancel this, you will get 3 by 2 times 10 to the power of 14. Okay, so 3 by 2 into 10 to the power of 14, or 1.5 times 10 to the power of 14. So gamma 1 minus gamma 2 is calculated. Okay, now what else? So this our labor has completed. We have got the value. Now let's check the answer. Check our previous solution. So H is equal to E V2 minus V1, V1 minus V2 by nu 1 minus nu 2. Now let's put the other values as well. So H equals to 1.6 times 10 to the power of minus 19, E, right? And what is H1? H1 was, one of them was 9.6, another was 0.34. So 9.6 minus 0.34. So this is the V1 minus V2. Next is 1.5 times 10 to the power of 14. Okay, so now you can almost cancel them, almost. If you have calculated, you can calculate it, but for now I am approximating. You can almost cancel this 1.6 and 1.5. they are very similar. Now 10 to the power of 14, once it goes up, it becomes 10 to the power of minus 14. So minus 19 minus 14, they are brothers. So what will happen? So they will become 10 to the power of minus 19, bracket minus 19 minus 14. So you have taken the minus common, so they will add up. So 19 plus 14 is basically 10 to the power of 33, right? And 96 minus 0.34 is 0.62, or it will be equals to, there is a approximate sign because we have approximated is 6.2 times 10 to the power of minus 34 joule second. This is Planck's constant. Okay, this is the Planck's constant. So be careful while solving this question. This question is from your sample question paper. Okay, so even though you might feel this question is difficult, sir is solving difficult question, but this question is directly taken from your sample question paper. So you have to practice this question. Similar question might come in your final exam, but as you can see, values are given such that most of them will be cancelled automatically if you are solving it properly. That is the beauty, right? Next question. A 60 watt source emits a monochromatic light of wavelength 663 nanometer. Okay, find the energy of one photon, calculate the number of photons emitted per second. So we have a 60 watt source. 60 watt source means the power consumed by it is 60 watt. Okay, in 1 second it is emitting 60 watts, so 60 joules per second is the energy emitted by this source. Now we have a light. The light that is being emitted, the light emitted is 663 nanometer, almost red light, right? So it's a red colored bulb. Now what is the energy of one single photon? So energy of one single photon, say E1, is basically h nu, right? So h nu is the energy of the photon emitted, one photon. Okay, now what is nu? As I just said in your previous problem, nu is c by lambda. So here we will directly use the values. Value of h is 6.63 into 10 to the power of minus 34. C is 3 times 10 to the power of 8. And lambda is given here 663 nanometer. 663 nanometers means 663 times 10 to the power of minus 9. Right? So this is the wavelength. Now if you calculate, you see that this is also getting cancelled. 6.63 divided by 663. What is the value of this? So if you remove the decimal two decimal places, so there will be 2 zeros, so you can cancel them and you will get 100. Okay, so basically it is nothing but 1 by 100. Clear? So now let's calculate it. It will be 10 to the power of minus 34 times 3 times 10 to the power of 8 divided by 100 times 10 to the power of minus 9. Okay, so 10 to the power of minus 9 minus 100, it will reduce to 10 to the power of minus 7. Minus 7 will go up, 10 to the minus 27, minus 27, so it will be 3 times 10 to the power of, so let me check it once more, 10 to the power of minus 19. So this is the energy of each photon. So energy of each photon is 3 times 10 to the power of minus 19 joules. Okay, energy of each photon is 10 to the power of minus 19 joules. Now what? Now we have to calculate the number of photons emitted per second. So now say number of photons emitted per second, say, is equals to n. Number of photons emitted per second is n, and each of the n has this much energy. Okay, so n times 3 times 10 to the power of minus 19, this is the total energy emitted by the bulb, right? So the total energy of the bulb is given by 60 watt. So this should be equals to 60, right? So this is the part A, this is part B. Right, so this is the energy of one single photon. This is the total number of photon. If you multiply, then you should get the total energy. So n should be equals to 60 divided by 3 times 10 to the power of minus 19. So you will get 20, or you will get 20 times 10 to the power of 19, or 2 times 10 to the power of 20. Okay, so this is the number of photons emitted per second. So this is the number of photons emitted per second. So 2 into 10 to the power of 20 photons emitted per second. So light is huge. So if you are switching on a LED light of 60 wattage, then the photons emitted by it is huge, right? Now next question. Light of wavelength 331.5 nanometer is produced by an argon laser, which is used to the photoelectric effect. When the light from the spectral line is incident on the emitter, the stopping in bracket cutoff potential of the photoelectron is 0.38 volt. find the work function of the material from which the emitter is made. So basically again we have to use the Einstein's equation, okay, that is h nu equals to work function plus what is given, stopping potential. Stopping potential given means we have to use the same formula, EV naught. Okay, the only thing is here the application of the formula is different. In last case we have to compare two different equations, subtract it, but here only one equation is given. Okay, wavelength is given. So first wavelength is given means lambda is given, lambda is 331.5. okay, so what we will do, nanometers means first we will convert it into meters. 331.5 times 10 to the power of minus 9 meters. Okay, so let's see what is h nu. H is 6.63, okay, times 10 to the power of minus 34, and nu is c by lambda, right? Nu is c by lambda. So let's put the value of c is 3 into 10 to the power of 8, and lambda is this 331.5 times 10 to the power of minus 9. Now what is this? What is the relationship between this and this? So you have to be careful to understand that 331.5 into 2 is basically 663. Right, so 663 is basically twice of that, so 6.63 divided by 663, it was 1 by 100 if you remember. If you remember, that was the answer, right? But what will be the answer if it was 331? So if we multiply down with 2 and up with 2, we know this value is 1 by 100, right? So it is basically nothing but 2 by 100, that is 1 by 50. As simple as that. So if you cancel them, you will get 1 by 50. Okay, so it will be 3 by 50 times 10 to the power of minus 34 minus 9, that is 10 to the power minus 25, minus 25 plus 8 is minus 17. Right, you can check that. 9, it will go up, it will become plus 9 is 17 minus 34 is minus 17. So you can make this as 3 by 5 times 10 to the power of minus 18 as well. So we have taken this 0, multiplied in the up, so it is now 3 by 5 into 10 to the power of 18. So h nu part we have calculated. Now we have to calculate the EV part and subtract it to calculate the work function. Okay, so now what is EV? EV is, E is 1.6 times 10 to the power of minus 19. Okay, what is V? V is given 0.38. Okay, so you can multiply it. It will be almost equal to 6.4. 6.3, almost equals to 6.3, and you can simplify this as well. This will be 0.6 10 to the power of minus 18. How I got this 0.6? 3 by 5 means 0.6. Okay, so this will be almost 6.2, 6.3. You can use the calculator to calculate the exact value, into 10 to the power of minus 19, or because it has 10 to the power of minus 18, let me simplify this and we will get 0.63 times 10 to the power of minus 19. Okay, 10 to the power of minus 19. Now what is the, if you check this function, what is the work function phi? Phi is nothing but h nu minus EV naught, right? Sorry, EV naught minus h nu. No, h nu minus ev naught, h nu minus ev naught, that is correct. So I think it will not be 0.63, it will be slightly less than that. Okay, there was some calculation error in this question because the values are not given properly. So let's assume that the cutoff potential is 0.3 volt, not 0.38 volt. So now if the cutoff potential, the stopping potential is 0.3 volt, then this will come out to be 3 16s are 48, so it will be 4.8 and it will be 0.48. Okay, actually we are getting the work function as negative, which is not possible, so that's why I had to adjust these values. Okay, these values, it is taken from your NCERT book with slight value modification, so the value modification may not be accurate, so that's why the answer is not coming exactly, because NCERT value problems are, even though their problems are good, the calculations, the values are well not thought of. It was done by maybe some of the people who are not familiar with the problem solving skills of the students required, so that's why they give the data randomly. Okay, but don't get afraid. Now let's put the values here. It is 0.6 times 10 to the power of minus 18 minus 0.48 times 10 to the power of minus 18, so you will get 0.12 times 10 to the power of minus 18. It will be in joules. Everything is in unit of joules, so this is in the unit of joules. So the work function is in the units of joules, and you can even calculate it in terms of EV as well. So I am giving you a small homework. Okay, what is the homework? That phi in terms of EV. How can you calculate that in terms of EV? So phi we have calculated in terms of joules. So just divide it by 10 to the power of minus 18 divided by the charge of a electron, so 1.6 into 10 to the power of minus 19, and let me know the value in the answer in the comment below. Okay, so exact this value will be in EV. You can leave the answer here, you will get full marks. You can convert it into electron volt, the answer will be slightly better looking, that's it. Otherwise there is no change between this answer and that answer. Okay, I hope you enjoyed this session, and if you are still struggling with your PU board preparation, then worry not. Diksha is presenting PU2 Success Blueprint Test Series, where we are trying to help you to achieve maximum possible marks in your upcoming PU board exam through a dedicated test series for your PU board. Okay, one of a kind thing, and here you are getting 4-part test series like your quarterly exam schedule. Okay, there will be 4 parts. We have divided the entire syllabus into 4 different parts. Once you join this program, you will be aware of all the parts. Okay, and 4 parts. Through these 4 parts, entire syllabus will be covered first. Then there will be dedicated 8 full syllabus questions. Okay, 2 per subject: physics, chemistry, maths, biology and CS. Okay, biology or CS, basically they are optional, any one of them you can attempt, and 3 for physics, chemistry, maths, and 1 either biology or CS. So total 4 subject. Each subject will have 2 questions, 2 full length paper each. Okay, and this question paper is not only it, you will get a fully PDF solution with the marking scheme available, and also you will get a video solution with complete detailed explanation by one of our experts. I am also part of it, obviously, and everything you are getting this for $5.99. The test series already started from this Sunday, so if you are still waiting for it, don't wait before next Sunday comes. Next Sunday there will be one more test. So please, if you want, you can join it, and it is exclusively for PU board of Karnataka board students, right? I'll be back with a new video of this Brahmastra series. This will continue as it is going on right now, as completely free of cost, and you can watch all the Brahmastra series in our channel. You can watch all the cassette series in our channel, but only for those who wants to score little extra in your PU board. For them, they can purchase the Success Blueprint Test Series, right? So I'll be back with a new video on Friday. Till then, bye.